1, 2, 3, 4. Look, it's working. Start recording. Okay, so this is actually section 994. Okay, we're going to go backwards to 9.3 in a minute. So what the proportional parts conjecture says, which is C94, if two triangles are similar, then the corresponding altitudes, medians, and angle bisectors are proportional to the corresponding sides. So say, for instance, that I told you, very simple case. Does my freehand shape tool work? I'm just going to see. Where's my freehand shape? I don't know. It wasn't working before, but we'll see. Does that work? It doesn't work. Okay. Never mind. Well, I'm just going to draw a triangle anyway. So here's one triangle. Here's another triangle. And let's tell you that these two badly drawn triangles are similar. Okay? So if I know, like, this is an angle bisector, and this also is an angle bisector over here. Okay, let's put 2 slashes on this one. And say I know that this is 4, and this is 5, and this is 3, and this is x. So this thing is a what? What's this line with the x on it? Can you see that? Oh, that's a. What is this called? If it cuts that angle in half. Not an altitude. It's an angle bisector. So if the triangles are similar, so this little squiggle says these are similar, then the angle bisectors are also proportional. So you could set up a proportion 4 is to 5, as this is a 3 over here, as 3 is to x. Am I recording? I am. And then you just cross multiply. 4x equals 15. X equals 15 over 4, whatever that comes out to be. What's that? 4 goes in there 3 times 3 and a half. No, 3 and 3/4. 3 and 3/4, right? 3 and 3/4. So, and sometimes people say, well, this is a 3 here, by the way. Okay? Can I do it this way as well? Can I say 4 is to 3 as 5 is to x? Yes, you can. It works out the same, right? 4 is to 3 as 5 is to x. So side is to angle bisector as side is to angle bisector. Notice when I cross multiply, I get exactly the same thing, right? 4x equals 15, right, which is what I got here. So you get the same answer either way. Yes? No? Okay? So that's pretty much all that proportional parts thing says. So if you were to see, oh, not the proportional parts, the one that says, proportional parts conjecture. Says that. So let's just do another one. Let's try to draw a better triangle this time. Better triangle. It's going to be a, is it going to be a right triangle? Let's just, oh well, I'll make a right triangle. Let's make any triangle. I can't really twist it, I don't think. Here's a triangle. Here's another triangle. Well, let's do it upside down and backwards. Say I tell you that here's A, B, C. Here's D, E, F. Okay? And say I put a point right here. I go like this, I go like this, I go like, and I tell you that triangle ABC is similar to triangle DEF. And maybe I'll tell you that this side is 10, and this side is 6. And I tell you that this segment going from here to here, what does that look like? Let's say that's 12, okay? And I want to know A, B, C, D, E, F. And I draw another segment from here to here, and I'm going to go like this. Okay? And I want to know what is, we'll call this x. What's x? How would I figure that out? What are these things called? Do you remember from last semester? What's that called? If it goes from one triangle to the midpoint of the opposite side. That's the median, okay? So the medians are also, right? These are medians, this thing and this thing. So if I tell you that these triangles are similar, then the medians are proportional to the sides, right? So I could set up a proportion that 10 is to 6, as 12 is to x. If you want to, you could reduce this first and then cross multiply, but you get 72 equals 10x, x equals 7.2. Easy enough? Easy enough? Okay. The one that is not totally obvious is the next conjecture. And I could show you this on GeoGebra, but I don't want to take the time. I don't want to give you time to work. So you need another minute to write that down. Next one that isn't totally obvious, and normally I'd have you discover this if I want to spend more time, but I want to give you some time to work. Okay? If I have some, does this have to be right? I wish I had my triangle drawing too. I'm just going to try to draw freehand, well, with lines. Here's some triangle. Here's a triangle. Got it? And if I draw the angle bisector of any angle, okay? So an angle bisector does not necessarily hit the middle of this other side. So if this is an angle bisector right here, okay? All they tell you is that this is an angle bisector, and this is A, we'll call this A, we'll call this B, we'll call this C, and we'll call this D. Conjecture C, what number is it on there? Sorry, C 95. The angle bisector opposite sides conjecture says that a bisector of an angle in a triangle divides the opposite sides into two segments whose lengths are in the same ratio as the length of the two opposite sides forming the angle. So you really need to kind of commit this to memory because it's not a completely obvious conjecture. So in other words, if this is an angle bisector indicated by these two angles being congruent, it divides this opposite side up into the same ratio as these sides. In other words, A is to B as C is to D. Okay? Another equivalent expression would be A is to C as B is to D, right? Because if I cross multiply either way, I get AD equals BC, right? So this over this equals this over this. See that? Yes? No? Yeah. So this is to this as this is to this. Or you can say it this is to this as this is to this. So let's do a tricky problem. Say I were to tell you that this side is, let me do another picture with my straight lines. Okay? Different color. Okay, so say I tell you that this is an angle bisector, indicated like that. All I tell you is that this side over here is 6. This side is 8. This whole side is 10. Which would make this a right triangle, by the way. Okay? Right? Because it's so it's not really proportional. I want you to find x. That's not a very good x. to find x. I want you to find y. Who can tell me how to set that up? Who can tell me how to set... You don't want to have two variables, right? So 6 is to what? 6 is to what? X, not 8. Okay, 6 is to 8. As what is? X is to y, yes, but I can't really use two variables because then I can't solve it, right? What could I call this in terms of 10 and x? How big is this? 10 minus x, right? Right? If this is 10 and this is x, then this piece over here is going to be 10 minus x, yes? So then you get, as x is to 10 minus x. You guys understand where that came from? Now I can cross multiply, and I get 6 times 10 minus x equals 8x. I get 60 minus 6x, whoops, 8x, sorry, equals 8x. I get 60 equals 14x. Why do we always have to get such bad numbers? And x is equal to 60 divided by 14. What's that equal to? 30 divided by 7. I don't know what that is, okay? And y, therefore, is going to be 10 minus 30 over 7. Which is equal to, how many is it? That's 70 over 7. So that would that be 40 over 7? 40 over 7. Is that right? 40 over 7, and yeah, that'd be right. So if x is 30 over 7, which is approximately equal to something, then y would have to be 40 over 7. Sorry my numbers don't work out, but that's how you do it. Okay? Okay. I'm going to give you, what time do we get out? Like 12 or something? 1:50. I'm going to let you work for 20 minutes, then I'll teach you the next thing, because this is kind of too much all at once, okay? So work on, I'll write the assignment down, or if you get it off of Schoology. I'm going to